Since this seemed to be a little bit of an issue today, I wanted to give you one more example of the tough stoichiometry problems where you have to do limiting reagent and they ask you for what's left over and you have to take into account what is the percent yield. So I picked a question from the study guide, which was number 70. And this was the balanced equation. So we have potassium chlorate and what's called red phosphorus making P4O10 and potassium chloride. So if you're analyzing a question, okay, this one gives you two values for the initial substances. So we have 94.6 grams of this and we have 65.3 grams of the P4. And then it tells us what we produce. So it says we make 21.0 grams of this. Okay, we cannot assume that that is the theoretical value. That's what we call the actual value. Okay, but them telling us that information at least lets us know like which product to look at. So when we're figuring out what's the limiting reagent and what's the theoretical yield, then we know we can go ahead and just compare it to KCl, and that way we're getting some of our work done for the eventual problem where we have to solve for percent yield. So the first step in this question is solve for theoretical yield, which we have to do by setting up two stoichiometry problems and figuring out which one is the limiting factor, and then using that one to figure out mass. First step is to turn both of the reactants into moles, and then the second step for both of them is to use the mole ratios to predict how much potassium chloride they can make. So the ratio of potassium chlorate, of potassium chloride to potassium chloride, there's 10 KCl's for every 10 KClO3, and there are 10 potassium chlorides for every 3 phosphorus. So what this tells us is with the amount of potassium chloride that we have, we could make potentially 0.772 moles of potassium chloride. Okay, with the amount of phosphorus that we have, we could make up to 1.76 moles of potassium chloride. So that means this is our limiting reagent. Okay, our theoretical yield of potassium chloride is 0.772 moles. So we need to take that to the next step, 0.772 moles of KCl to get the final answer for theoretical yield. We're going to turn that into mass by multiplying by the molar mass, which is 74.55. So our theoretical yield of KCl is going to be 57.6 grams. That's part one. So the tougher part to get your head around is when they're asking how much of the excess reagent is left over. What you have to realize is you need to use your product to figure that out. So if your reaction actually worked 100%, we just figured out that we would be making this many moles. If we had 100% yield, this is how much product we make. So we need to take this number of potassium chloride and turn it back into phosphorus to see how many moles, how many grams of phosphorus we would need in order to create that potassium chloride. The question told us that we had an available amount, but we just realized in the beginning of this problem that we didn't use it all. So we did not use all 65.3. Okay, based on how much product we made, we can figure out how much of that 65 grams we actually used. So I'm going to start with 0.772 moles of KCl and flip it back into phosphorus. So we use 3 moles of phosphorus for every 10 moles of KCl, which means that for this question we used 0.232 moles of P4. So this is how much P4 we actually required for the reaction. If we want to find out the mass of that, okay, we're just going to multiply by the molar mass, which is this. Okay, and that means that we used 28.7 grams. Okay, so how much of the excess reagent is left over? So we had 65.3 grams available. We just figured out based on the amount of product that we made that we only used 28.7. So that means our leftover excess reagent was 36.6 grams of phosphorus. And then the last step of these questions is percent yield. So our theoretical yield was 57.6 if 100% of everything actually went perfectly and worked out. The question originally told us that we only made 21. So to find percent yield, you take the amount that you actually made divided by what you theoretically should have been able to create and multiply it by 100. So this reaction was only 36.5% proficient.